Hi, hello friends. Welcome back to my YouTube channel. Let's continue our discussion of UPPCL AE paper. Now the question here it is: a diesel power station has a fuel consumption of 0.98 kg per kilowatt hour. The calorific value of the fuel being 10,000 kilocalories per kg. Determine the overall efficiency. Now here the fuel consumption is of 0.28 kg per kilowatt hour. So for 1 kilowatt hour they are using fuel of 0.28 kg, and this one uh, the calorific value of the fuel being is 10,000 kilocalories per kg. So per kg it is 10,000 kilocalories. Per 0.28 kg how much? So let's take the formula first here. The overall efficiency is equal to, if you want in percentage you can take percentage. Efficiency is equal to electrical output in kilocalories. So electrical output in kilocalories divided by, so input in the same unit, kilocalories. Now the electrical output is, let it be 1 kilowatt hour. So 1 kilowatt hour is nothing but 1 kilowatt hour. It can be written as 860 kilocalories divided by the input is in kilocalories. So how much for generation of 1 kilowatt hour, how much fuel required? It is 0.28 kg of the fuel, and the calorific value is, it is 10,000. Now 860 divided by, so 0.28. So here take a percentage, means we will multiply it with 100 here. So 860 into 100 divided by, so 28, it is 00 here. Now by making the cancel here, the answer will be, it is around 30.07. I'll write here again, 30.7 percentage is the right answer for this question. So we'll move to the next question here. Now 32nd question. Let's see here. The operation of all induction instruments depends on the production of torque. It is due to the reaction between the flux and the eddy currents induced in the metallic disc or aluminum disc or drum by the flux, another flux phi 2. Okay, the phi 1 and phi 2 depends upon the current or voltage to be measured. So phi 1 depends upon the voltage, second phi 2 depends upon the current. So why? Because it's an induction type instrument, the phi 1 phi 2 will be produced by this voltage and currents. Okay, and in order to make the difference between these two, so we'll make some copper rings, other things here. Okay, no, the right answer for this question is C. Next question. Now identify the following series. So in the identification of the series here, f of x is equal to f of 0 plus x into f dash of 0 plus x square by 2 factorial f double dash of 0 plus x cube by 3 factorial f triple dash of 0 plus 2 up to infinity. So this series is Maclaurin's series here. And the next question, 34th question here, it is an energy meter with a constant of 600 revolutions per unit is used for the energy measurement. It makes 500 revolutions in 30 seconds. Okay, find the energy consumed by the load for an hour. Now here, the what is the value K given? So K is given as 600 revolutions per kilowatt hour. So K is nothing but 600 revolutions per unit or kilowatt hour I can take. Now the instrument is making 500 revolutions in 30 seconds of time. Now in order to, for 1 hour, so for 1 hour it is going to make, so 500 into 120 k revolutions. Now energy recorded is, okay, so energy energy recorded is equal to, the formula is number of revolutions made by disk. So number of revolutions made by disk, it is how much? It is 500 into 120 divided by energy meter constant. So energy meter constant is how much? 600 here. So for this formula already we discussed in the previous videos, so that's why I am not repeating the same formula here. It is equal to, so you will get it as a 100 units. Okay, so answer is 100 units here. Now next question, 35th question here, it is from the control system and as well as from the signal systems, right? So mixed question here. So x of t is given, the multiplier is given here, cos omega t is given, and y of t is equal to x of t into cos omega t is given. Now the system is characterized by, it is casual and memoryless and BIBO system, bounded input and bounded output stable system here. So we'll move to the next question here. Now this question is from the electromagnetic fields. Okay, now the charge in the form of a plane sheet with density rho s is equal to 40 microcoulombs per meter square, located at z is equal to minus 0.5 meters. A uniform line charge of rho l is equal to minus 6 microcoulombs per meter lies in the y-axis. What net flux crosses the surface of a cube 2 meter long on edge and centered at the origin. So here the formula here is going to be the charge enclosed by from the plane is equal to, so how much it is? It is 4 meters square. Why? Because it's going to 2 meters cube, now area is nothing but 4 meters square into, so 40 microcoulombs per meter square. So it is answer going to be 160 microcoulombs. And similarly the uniform line charge of minus 6 microcoulombs along with the y-axis. Now for line, the charge enclosed from the line surface, so line which is equal to minus 6 microcoulombs per meter into cube of how much? 2 meters, so it is 2 meters, so totally it's going to be minus 12 microcoulombs. Now the total charge, the total net flux crosses the surface is, so total is going to be 160 minus 12 is going to be 148 microcoulombs. Answer is B here. Next one, gradient is a vector and defined for a point in a scalar field. Okay, so those are the direct theory questions. Next one, 38th question, a hot wire instrument deflection is, so deflection hot wire instrument means it depends upon the RMS value of the current flowing and generally it is proportional to I square. So generally it's going to I square, so I square R, hot wire instrument means I square into R. Next one, 39th question. Now here in this question, find V3 and its polarity if the current is 0.4. So directly we can apply KVL here, so minus 50 and here the current flowing, it is plus minus, so already it is given 5 and the current is 0.4 plus 10 plus 20 into 0.4 and you are coming here plus and minus, we can consider as a VBA is equal to 0. Now VBA is how much? VBA I will get it as a 30 volts. It means that VB minus VA is equal to 30 volts. So B is at higher potential, A is at lower potential. So let's see the answer here. Now V3 is at 30 volts where the B is a positive terminal and with respect to A terminal. So right is the right answer. And the next question here, find the average load voltage of the rectifier if the device is switched on at an interval alpha at a alpha angular value. Generally, so this is an half wave rectifier circuit where the output voltage V naught is, so V naught is equal to Vm by 2 pi into 1 plus cos alpha. Generally here what they asked is Vrms is equal to Vm by root 2. If you substitute here, Vm is means Vrms into root 2 divided by 2 pi into 1 plus cos alpha. Again if we simplify this one, you will get it as Vrms, so you will get it here root 2 into pi into 1 plus cos alpha here. So answer here it is B. Thank you friends, thanks for watching my video.